This is one of the easiest things to learn when cooking. Boiling a porridge. Add some grains, usually oatmeal, to some milk or water, season with salt or sugar and then let it slowly simmer until ready. Compare this to a barbecue. Flipping a hamburger or preparing a steak on the fire seems to be a jealously guarded male privilege. No matter that cooking is mostly done more by women, of course. So important it seems to be. So why then, if it is so seemingly simple, has the starch-based diet come after the meat-based one in our human development? Hello and welcome to this 10th episode of Edo Ergo Sum, I am what I eat. Here we have a closer look at what we are actually eating, and this on a more basic level, chemistry. And why it took quite a while before a starch-based diet became widespread. Most life on Earth is based on the chemical element carbon. This is not because carbon is so abundant, other elements like iron or oxygen are much more common on this planet. But carbon is tetravalent. It has 4 connections to bond with other atoms. Just imagine a Lego brick with knobs on 4 sides to connect to other Lego bricks. This makes it a very useful building block out of which complex molecules can be formed. As a consequence, carbon has the largest variety of chemical compounds of any element. This property makes it the foundation of life on Earth. However, most carbon found on our planet is inorganic. It is not part of a life form. In fact, 99.8% sits here. In limestone. Is a piece of limestone I have bought in a home improvement store. Cost me about 35 cents. So most carbon sits in stone formations like limestone, which has the chemical composition of CaCO3, calcium carbonate. Despite oil and gas companies being among the most valuable on this planet, the carbon in all coal, oil and gas deposits together is a negligible quantity compared to with what sits in stone. A minuscule portion of the Earth's carbon, 0.1%, is part of another inorganic carbon molecule called CO2, carbon dioxide, which can be found here. It's the bubbles which you can see in this glass. Carbon dioxide can be found in both air and water and has become famous as the gas mostly accused of changing our climate. The tiny rest, again 0.1%, is what most life forms are made of, among them we and everything we eat. By using a process called photosynthesis, plants and bacteria have managed to use the energy they receive from light to break up water into its elements hydrogen and oxygen, and combine these with carbon dioxide taken from air or water to turn both these inorganic substances into an organic one, a simple sugar called glucose. When the simple sugar breaks up, it releases the energy that has been put into it during its production. This makes it the basic fuel for most life forms on Earth. When the sun is shining and the temperature is right, a plant produces more energy than it needs at the moment, so this excess has to be stored. Plants have developed several forms to deal with this challenge. The most simple one is to store it fairly unchanged as sugar. This is what most fruit consists of. Since sugar is a solvable substance, it is generally stored together with water. This makes fruit so sweet and juicy. However, for a plant this has some impracticalities. Storing energy in that way gobbles up a lot of space and is heavy as it binds much water that has no energy. This is why plants have developed other, more sophisticated ways to store this excess energy. A very compact way is to convert the sugar into fat. When a high amount of energy has to be crammed in a small space, a plant does just that. Seeds and nuts have a high fat content, as this provides the next generation with a compact energy reserve as a head start. Our own excess energy is also mainly stored in fat to save space and weight. Fat has, however, drawbacks too. It resists water, so can't be easily transported. It also has a chemical structure that is more complex than sugar, so converting one into the other requires effort. This is why a simpler solution has been found to the storage problem. Stick the sugar molecules together into chains. These chains are called polysaccharides, from Greek poly meaning several and saccharide meaning sugar. The most important of these are cellulose and starch, which serve different functions in a plant. The most widely available is cellulose. This is what the plant's cells are made of. It gives them structure and rigidity. This makes digesting it quite a challenge. Plants can do it themselves, they need it when they have to grow, so they have an enzyme called cellulase that converts cellulose back into sugar. Grass-digesting animals such as cows or horses have managed the same trick with the help of specialized bacteria that use the same sort of enzyme. For us, cellulose has a different function. It serves as our body's waste transporter. It is part of what comes out of our body at the other end. We can access cellulose energy only in indirect form, by drinking the milk or eating the meat of a cellulose-eating animal. For a plant to use cellulose as an energy source would be the equivalent of burning your house down to keep warm, so not a practical long-term solution. For that, the other polysaccharide, starch, comes into play. Starch too is non-soluble, not an acid, but in contrast to cellulose can be converted back into sugar quite easily by a plant. As humans we can digest starch, but in its raw form only in our colon with the help of specialized bacteria. This takes a lot of time, does not extract much energy, and produces flatulence. Prehistoric man discovered that adding hot water to starch resulted in its gelatinization, a process where the presence of heat and water results in the breaking down of bonds between starch molecules. This allows it to take on water. That is why 100 grams of raw spaghetti become roughly double that weight after cooking. Gelatinization makes it possible to digest starch not only in the colon, but also in the thin intestines, greatly increasing the amount of energy that can be absorbed, and at the same time reducing flatulence. It is, however, safe to say that to prehistoric man the appeal of eating with less shame was much less important than the extra energy intake. This is exactly the opposite of what is now suggested in some diet books, that advise you to eat cooked pasta cold or reheated, to profit from starch retrogradation, the opposite of gelatinization. This makes starch harder to digest, which means that we receive less energy from it and, as a consequence, supposedly lose weight easier. Remember from episode 2 about the control of fire that cooking had a force effect on food? To alter it. This made starch greatly more valuable as a food source, and the combination with water enabled us to extract more energy from it. Since this is a more complex innovation than simply roasting a mammoth's leg over a fire to make it more tender, it is no accident that this process happened later. Starch did not only have to be heated, in most cases it also had to be combined with water to provide the energy boost required. Since bread is in its most basic form a combination of starch with heated water, the discovery in the Jordanian desert that was discussed in video 5 shows that this process was known before the agricultural revolution has taken place. The revolution simply meant a scale-up of an established production process to make starch the primary food source for mankind. It still is so today. Wheat is one of the top food items we consume. With the agricultural revolutions, most humans changed from primarily meat eaters to become primarily potato, rice, wheat, or maize eaters. Now that we know why the change to a starch-based diet happened later, It is time to look into what impact the agricultural revolutions have had on what we eat today. This, however, I have to show you in my next video. The revolutions today. Thank you for watching this episode of Edo Ergo Sum, I am what I eat. If you did enjoy it, please hit the like button, this would help other people find it on YouTube. If you want to receive more videos like this one, also about the present or future of our relationship with food, consider subscribing to the channel. What do you think? Is it logical that to eat starch on a large scale came later than eating meat? Please leave your remarks and questions in the comments. I really appreciate your input. Bye for now. Hopefully to the next video when the subject is the revolutions today.